All right. Did I mention you guys we have a quiz on Tuesday? Usually I write that information on the side board over there, and I will write that on there today. There's a quiz on Tuesday. The quiz will cover everything that we've had up through today, up through the end of today. That's the first 4 sections. Okay? Whatever we do on Monday will not be in the quiz. Other than if we have a review, and I think we're going to review a little bit on Monday. Okay? You don't have to be real quiet, but if you have questions, ask me questions. Just don't say anything stupid. We don't want anything stupid on any of the recordings. Right? Okay, good. All right, today. Talk about direct variation. It's not a lot different than what we did the other day, because it's all about linear equations. The only thing that's different is that our y-intercept is going to be 0. So if it's direct variation, all these lines will pass through the origin. Let me give you an example. A direct variation equation will look like what is K? Well, K is called a constant. And that can be any real number. Maybe an example might be y equals 2x. Y varies directly as twice whatever x is. Okay, notice there's no y-intercept. There's no plus b. Our y-intercept is always 0, always passes through the origin. In words, it'll read this way. Y varies directly as x. If y varies directly as x, we get this equation, y equals kx. And k is called the constant. It's called the constant of variation. Y varies directly as whatever that constant is. Okay? All right. Well, let's take an example. Here's a test question you might say. By the way, how would I find k? How would I find that constant? If y is equal to kx, what is k equal to? Y divided by x, sure. Yeah. It's the ratio of y to x. Ratio. Rational. Rational numbers, a fraction. A ratio is a fraction. By the way, do you like the lamps?
Yeah.
Okay. I think it's better than the overhead lights. The overhead lights, I don't like it all. I changed and used lamps about 5 or 6 years ago, and most of the lamps here are donations from students. Some I bought at Target, $7.99. These ones up here, $7.99. The ones in the back, the ones with the ships.
I got pirate ships.
Yeah, they were my parents' lamps back in the early 70s. They bought those lamps. And a couple of years ago, I went over to my dad's, and I went down his basement. I said, "Dad, you want those lamps?" He says, "No." Great, they're mine. So I took them. Anyway, I like the lamps. Well, in order to find K, so maybe we have a. Was that the hallway?
Yeah.
All right. So maybe we have a table of values, and they might ask you, take some points here. And the question might be, does this represent direct variation? Well, if it does, then the ratio is going to be constant. Y over x is 3, or 3 and 1, or 9 and 3. 9 divided by 3 is 3. 15 over 5 is 3. 21 over 7 is 3. We have that same constant. Y over x is 3 in each case. And so that constant of variation is 3. It varies directly. The equation of this line would be y equals 3x. Okay, direct variation. All right. So here's a test question. Y varies directly as x. And x is equal to negative 3 when y is equal to 12. All right? So we have a three-part question now I'm going to ask you. Find the constant of variation, find the equation of variation, and find y when x is equal to 17. So we have a three-part question. Okay, it's not very hard. It tells you that y varies directly as x, so I know I'm going to look at y equals kx. Then you have other given information that says y is 12 when x is negative 3. So my constant of variation would be what? Negative 4. That's my constant of variation. Very simple. Simply y over x. Is that okay?
Will it always be right if you just put like y over x, because that's okay?
Yes, it'll always be right if you get y over x, because they told you that it varies directly as x. Right, that's part A. Part B. Give me the equation of variation. Well, that's easy. Now that we have the constant, it's simply y equals negative 4x. That's the equation of variation. Part C. Find y when x is 17. So y is equal to negative 4 times 17. And so the y value is negative 68. Okay? Anybody think of a different way to do this problem?
Was the first one use ratio?
Absolutely. Ratio and proportion, you can do that. Because of the ratio of x to y is negative 3 over 17. I'm sorry, negative 3 over 12. That's your ratio. The top is your x. And it doesn't matter. We could put 12 over negative 3 too. But negative 3 and 12. Negative 3 is your x. Y is your 12. Then we want to find y when x is 17. Okay? And what is that? You have one ratio equaling another ratio. And that forms a what? It forms a proportion. And how do we solve a proportion? Cross multiply, yeah. So that means that negative 3y is equal to 12 times 17. It's 12 times 17. 204. Okay. Divide by 3. Negative 3. What do we get? Somebody tell me. Negative 68. Somebody tell me how I multiplied 12 times 17 and came up with 204 so quickly. And it's not because I'm a math teacher. Yeah.
Numbers like that, like 10 times 10, that's 100, and then 7 times 2 is 14, and 7 plus 2 is 9, so you just had to make that 90, and then you do 14 plus 90 plus.
Oh my. Do you think I did that in my head? Maybe you could, and I think that's great. When I do multiplication of big numbers on the board, I very rarely will use a calculator. Or sometimes I may ask you for numbers. But here's what I do very quickly. Because when I learned math, there were no calculators. Couldn't use calculators. All right, so, well, they weren't invented yet. Not that I'm that old, but maybe I am, I don't know. Okay, so what I did was 17 times, and I used distributive property. 17 times 10, well, that's 170. 170 plus 34. Okay. Easy. It's quicker than a calculator. Able to leap tall buildings in a single bound. Superman, probably. I don't know. Okay. I love Superman. Who doesn't love Superman? My favorite superhero. What? All right, here we go. Speaking of, look, when you're solving proportions, we know this to be true. 3/4 is equal to 9/12. We know that to be true. Okay, if I reduce 9/12, I'm going to get 3/4. They are equal to one another. And a property of proportions is that their cross products are equal. 4 times 9 is the same as 12 times 3. So maybe I'll have a problem that says x minus 7 over, I don't know, 8 is equal to x over, what is that? Solve for x. How do we solve? We cross multiply. 8x, 8 times x, is equal to negative 5x plus 35. By the way, when you do this, it's a good idea to put parentheses so that we're not writing negative 35. Adding 5x. But this is, I'm not just doing this just to show off. This is part of your assignment too. You don't have to, you don't have to do calculator work here. I'm not interested in a decimal where you have to round it. It's just simply 35 divided by 13. 35 over 13, that's it. Okay? All right. I want you to turn to page 36. And I want to get you started on one of the story problems that you have for homework. probably looking at that big paragraph saying, I'm not going to do that. It's like Joseph told Monday. Make sure that you guys are trying every single problem, including the story problems. Get something down in your paper. Try these problems. Every day usually I assign all the story problems. Okay? Because that's what life is. Life is a word problem. Okay? We need to know how to problem solve. And if you never take another math course as long as you live, you will learn how to problem solve. And that's a benefit of doing math. This particular problem says that scuba diver descends. The increase in water pressure varies directly. So we are going to have direct variation equation. It varies directly as the increase in depth below the water's surface. However, the constant of variation is smaller in fresh water than in salt water. So that constant's going to change depending if we're in fresh water or salt water. Now they'll give you some numbers to work with. For example, 80 feet below the surface of a typical freshwater lake, Long Lake, Dunham Lake, okay, those are freshwater lakes. We think they're freshwater. The pressure is 34.64 pounds. Before we do that, it says the pressure varies directly as the depth. Pressure increases as you go further down. The pressure varies directly as the depth, and I'll use P for pressure and D for depth. The pressure varies directly as the depth. Now we're talking about fresh water. At 80 feet, the pressure is 34.64. This is for fresh water. Are we able to find K? Sure. Just Y over X. In this case, P over D. 34.64 divided by 8. Then we'll find our K. We'll probably have to round it. Okay? I would say round your answer to the nearest thousandths. The more decimal places you take out, the more accurate we can be. So you want to round to 3 decimal places. Okay. So somebody said it was 0.433? Okay. So let's just continue this out a little bit. Then the equation is going to be the pressure varies directly as the depth, and we have our constant of variation. So then they say, well, what if you're at 300 feet? Very deep lake. What's the pressure? Can we figure it out? Sure. 0.433 times 300. Now those numbers change for salt water when you get to the ocean. Okay, those numbers change a little bit. So I'll let you do the rest of it. But at least for at least we got you started on that problem. Okay. And I found, going through this book, that the information they give you in the story problems are not information that they just made up. These numbers are not made up. These are from actual true figures here. All right. I believe we've covered everything that I want to cover today for this new lesson. I did. So your homework is going to be pages 33 and 36, problems 50 to 57 thirds, and 66 through 70 all. Okay, that's homework.